Tribological behavior and acoustic insulation of geomaterial composites based on volcanic wood and sugarcane ash with expanded polystyrene. The aim of the present research was to synthesize and characterize acoustically and tribologically composite materials using metakaolin, polystyrene, volcanic bagasse, and wood ashes. For the elaboration of composites, the materials were mixed in the proportion described in Table 3. To each of these mixtures, a 4% sodium hydroxide solution was added, mixed and kneaded to later be molded in cubic molds. After 24 hours, the composites were demolded and pre-dried and then moved to a curing chamber for 28 days and finally finished drying with a heating ramp. The chemical characterization was carried out by means of X-ray fluorescence. The structural characterization was carried out with X-ray diffraction. The tribological properties were determined with the volume disk tribometer. The acoustic insulation was determined by the relationship of the values of T or speed of sound through the specimens and their respective density. In the fluorescence results, the presence of the elements aluminum, silicon, and calcium is observed, which are required to carry out the synthesis of these geopolymers. The average coefficients of friction for the specimens with metakaolin without and with polystyrene, volcanic ash without and with polystyrene are 0.53, 0.54, 0.55, and 0.57. This indicates that adding polystyrene increases the coefficient of friction, since the porosity is increased by the formation of polystyrene when applying the heating ramp. In the same order, the wear rates are 1.10, 0.69, 0.28, and 0.35, which is consistent with the density results, since the composites with metakaolin content, less dense, present a higher wear rate than the specimens with volcanic ash content, denser. Regarding the results of the acoustic test, samples 9A and 9B show the highest acoustic impedance in their respective groups. It is inferred that this is due to the calcium carbonate contents as a product of the pozzolanic reaction carried out by the elements visualized in FRX, Table 4. It was also observed that the impedance values decreased significantly for composite with polystyrene and for composite with volcanic ash. This is due to the size of the composites. This is due to the size of the porosities generated by these materials. The polystyrene, with a particle size of 1.5 to 2.0 millimeters, is deformed due to the temperature of the drying process. Therefore, the resistance of the material to the passage of acoustic wave 5,000 Hz is reduced. In the case of composites with volcanic ash content, the porosities generated are higher than in composites with metakaolin due to the particle size, 250 to 420 micrometers and 23 micrometers respectively.